So this is tutorial number 12. Estimate the thermal conductivity of air at 400 degrees Celsius and 180 m and compare with the measured value of 0.05015 watt millikelvin. So this is the properties of air at 180 m pressure here. Okay, so for this one, so we have the critical temperature as 238 Rankine, so it is 132.2 Kelvin. So I think we could get this one. It is 100 for 400 here, so we take the value of 400 here. So according to the measure, so we have the thermal conductivity is 8 point, sorry, thermal conductivity is here. Okay. So this is the idea. So the critical temperature we get it is around 132.2 Kelvin. So the temperature is 400 degrees Celsius, so which is the 673 Kelvin. So and then because the temperature is bigger compared to the critical temperature, but the pressure is much lower compared to the critical pressure. So we assume that this is as a low density. So and then for the low density here, we could use the power law estimation. It is quite simple because the idea here is actually we get from the comparison graph actually. So the idea is very simple because the idea of low density here is because the density not change too much, so the thermal conductivity actually can be proportionally changed compared with the temperature. But the power, the curve, the graph curve or the graph pattern need to be determined from the experimental works. That's why the calculation here we need to have an n here, because the n here is actually the value of curve fitting from the previous investigation. So for the low density here, so the equation is k over k naught and equal to T over T naught by the power of n, which is the K here is the thermal conductivity and K naught is the thermal conductivity of reference value. So this is always the K naught here. Normally we are taking the value at 180 m, or we taking any value from the table just now. So and then from a table, we know that the T naught is 273 Kelvin. So we take the thermal conductivity is K naught, and the value of N is equal to 0.81. So and then we substitute everything, we could get that the value of K is 0.05005. So and then but if we compare from the table that I show you just now, so the value is 0.05015. So the error is around 0.2%. So this is just to show you a few ideas when you have a little bit complicated, or when you do your research with different types of condition.